sample from that original source image, because I can't seem to pass the individual sprites across. So instead of that, I just create this look at the material, just pass the whole texture in here, and then what I want to do is just tell it which frame I want to pull out. So here I can pass this offset, and this is saying that I want it to be from the main text, which is the name of our texture that we've created here. And then the size is basically how big each pixel we want each pixel to be, and how much we want to extrude it. So essentially every pixels are like a rectangle. It's got a square, and then it goes back to the extruded depth. Well, it actually goes based on the center, so it actually goes forward and back at it. But anyway, that's the. So these are kind of the things that extras that we need to pass into the shader. Like uniform. This is a uniform variable, and this is a kind of a uniform, but it's sort of half built in with Unity, I think. It's and then we want to draw it. So if we look at the shader code now, the first stage in this is our texture coming in defaulting to white. So this is our main text, and this is just saying that it needs to be targeting 4 at least, because we're using a geometry shader. And so we're saying the vertex, these are the names of the vertex, the routines that we're using for our vertex fragment and geometry shaders. This is the input geometry shader, and the input to the fragment shader. But essentially, I've found some code which someone had written for billboarding, and that was a kind of starting point for how to write a geometry shader, and I just literally took their code and then just played around to make it do what I wanted. So I didn't, I'm quite new to this stuff. I mean, I've done some shaders in OpenGL ES, type shaders, but not working with CG, and not also not this kind of peculiarities that Unity introduces into it. But anyway, the principle's fairly similar, So here we are. This is our vertex shader. So at first it comes in here. We get the position and the normal. We're just passing it on to the geometry shader. This transforming. This is creating our offset. This is a kind of a macro somewhere in our ink, which basically just says add that texture offset that we're passing in to our original texture coordinate. So that sort of selects the frame, and then we're passing it onto our output here. And so then in the geometry shader, what we want to do is we want to actually create, for every point coming in on our flat grid, we actually want to create 6 different planes. So we've got these 6 planes defined here, which are sort of little mini triangle strips. So one triangle strip for each plane. So you need 4 points to define a triangle strip to define the 2 triangles, rather than 6 if it was, if you were to draw normal index triangle list, you would have to define the same points twice sometimes. But this strip just makes it more efficient. You just have 3. So these are our back face and left, right, top, bottom, front faces. I'm not doing anything to cull any of them, but like some voxel people that worked on voxel stuff would first work out if there's anything adjacent, and then only draw the planes. So if I zoom in here, just get on the decent axis for it. So if I zoom in, you can see it sort of cuts into when it clips, you can see the cubes are actually still fully drawn, even though I only really need to draw what's on the outside. But here I'm being lazy and just drawing everything. But to clean it up, you would probably just you'd ignore the inner planes. If you had a pixel that adjacent that you wanted to draw, you wouldn't draw that one. But it's not massive overhead, I don't think. Way better. So these are not for an object of this size. I mean, obviously, if you're drawing something massive, you want to be, you want to save that kind of extra work. And here this geometry shader allows you to to pass out. Here we're saying up to 24 vertices. So we're splitting out 24 vertices for one coming in. So for every one in our grid, we're splitting out 24. But this means that this is our maximum count. So if we wanted, we could sort of skip some of them that we didn't want to draw and only split out the ones we needed. So I've got these, two semicolons there. So I've got these up front right, and these are our vectors in those different directions that I'm using basically to as vector-based unit vectors that I can scale up to where I need. So this is half of the size that we're passing in. So we pass in these size values, which are based on the size of the grid and so on, so that each square meets up nicely with the one next to it for the horizontal and vertical. That's why we've got this divided by the columns and rows. Otherwise, you'd have gaps between them, or they'd be too big. And then this is our extrude amount, which is a property we can adjust to make how deep we want it to go. So then I get half of each of those, which is basically our offset amount in each direction. So I've got this, that's why we have pluses and minuses here, times these half U, half T, half S values. So that those are sort of combining these offsets by these amounts to work out where our front, back, left planes are. So that's that bit. Then here, I multiply by the model view projection matrix. So at the moment it always seems to be stuck. So if I click on the player object and move it, it always seems to be at the origin. So it seems to be ignoring our model matrix. So this is probably something I'm not figuring out here, because that I would think that our model matrix would be from the model coordinates into our world coordinates. So that should be in the M part of that MVC, was it? Model view projection MVP matrix here. So I may have to pass in something extra to pass in the position of where we want it in world space, but at the moment it's just at the origin. In any case, it's enough to make it visible to our camera. It demonstrates the point. So here we're passing in this offset here and texture coordinate, and we're adding it to the tri-stream. And here I'm saying if it's mod 4, which means basically for each of these, after each of these 4, we need to restart a new triangle strip. So I mean, if you're clever, you could go all the way around 4 of them and then start a new one at the top and start a new one at the bottom or something to make it slightly more efficient. But that's what I'm using that for. It's basically just to say after it's got these 4, start a new triangle strip, do these 4, and so on. Finally, in our fragment shader, so essentially what we've done is we've created a square for each grid, and we've passed the texture on. So it would have been nice to be able to sample the texture at an earlier stage, but for some reason when I tried to do this sampling in the vertex or geometry shader, it didn't like it. So I'm not sure if that's a CG thing, or maybe you can only access textures in the fragment shader, or I'm not really sure where that. But, so anyway, here our sampler is done in the fragment shader, and I take the pixel, sample that pixel to get the color, and here what I'm doing is this is just to check that the alpha, check the transparency. So basically, I'm saying if it's less than 0.1, I mean it should probably be 0, but I never really trust equating on floating points, you know, because of rounding errors and so on. So to say that it's less than 0.1, it's probably translucent enough that we don't want to draw it. So in that case, we just call this discard method, which prevents the pixel being drawn. Otherwise, we return the color, which will be the color for our particular pixel. And so that's basically our geometry shader. And no, you know, we're not doing any lighting or anything like that. We're just passing the pixel back out again if it exists, but in the form of a square or a rectangle. So you can see, I play this now. Our frames are coming through and being rendered as this kind of object here, rather than just as a 2D thing. And if you move above, move around, you can see it's not flat. So we're thinking on using this as for kind of slightly stylized 2D stroke, almost 3D gain. And this will be, we're starting with this character, but I think we're going to probably have to draw our own because we don't want to get copyright problems. But we're working on a game that's based on this Dangerous, if you want to check it out. My friend's really got this thing. He just wants to try and remake this thing because he loves it. But we'll see what it ends up being. Early stages, but thanks a lot.